This lesson is implement static properties and methods in JavaScript. The objectives for this lesson are to understand how to utilize the static keyword, develop static properties, implement static methods, familiarize yourself with static constructors, design utility classes. If we use the static keyword in front of a property or method, this makes that property or method only exist one time per class. Not through an instance of the class, but the class. So we access these through the class name, not the instance variable. Static properties are generally used to hold data that does not change very often, and we create static methods as utility functions that sometimes return something. They might create or clone new classes. They might load some fields from somewhere else, like a file. We use these a lot for caches, for configuration settings, or any data that only is needed one time per class. We create static properties by using the static keyword in front of a normal property definition inside of a class. You can also create static fields, so private static properties as well, by putting the pound sign in front of the name, just like we did before, again using the static keyword in front of that. Let's take a look at creating some static class properties in JavaScript. In this HTML file, I've created a class called movie that has our 4 properties that we've always been using, but now I've added 2 additional property definitions that use the static keyword. The first one, static counter equals 0. The second is static initDate equals new date. Now, like I said, these are now for all instances of the movie class. In the constructor, I'm going to increment that counter by 1 every time a new movie class is created. So if I look at the code down here, look at line 46, let movie equals new movie. So if I were to access the movie counter right now, I can't access it through the instance variable, right? Movie with a lowercase m, that's not allowed. However, I can do movie uppercase m dot counter and movie dot init date. Then we see on line 56, I create another instance of a movie. If I then access the movie class name dot counter, we should see that it's incremented by 1. Now, since these are simply public properties, we can both read and write to them. So I could increment the value outside of the constructor if I wanted to. And that might defeat the purpose for this particular one, because I really probably only want to keep track of how many were actually created, not by just setting the counter values. Now, the other thing is I'm going to go and show you here, I'm going to do a window.setTimeout. So after 2 seconds, I'm going to display lines 69 and 70, because I want to show you that even though I'm waiting for 2 seconds after this code has run, the init date has not changed. The init date is just the first time that the class was created when this page was loaded. It is not at the time that this code runs where the first movie one is created. It's created when this page loads and this class movie is created. The definition of it is created. That's at the time that the date is initialized. So let's go ahead and run this. We'll bring up our console window. We'll see movie.counter equals undefined. Okay, that's the first time. Then movie.counter is equal to 1. So I've created 1 time. You see the init date there. Okay, notice that init date. Now I'm going to create another movie instance. So you see the movie counter is equal to 2. I incremented the movie counter on my own. So I'm just showing you that the movie counter now after that 2 seconds has indeed been incremented by 1. But look at the init date is the exact same one after 2 seconds. It has not changed at all since the page was loaded. So it's very important to keep track of that these are only for the class itself, not each instance. Now, as I talked about, it might be a good idea to make these read-only properties sometimes. So we might declare our static properties as private using the pound sign, and then we use getters and setters as appropriate. Well, let's take a look at creating a static read-only class property in JavaScript. In this HTML file, I'm creating that same class movie. It's got the 4 public properties. I've got now static field definitions that are private. So I've added the pound sign in front of counter and init date. Then I've just created read-only property exposers, right? Static get counter, static get init date that simply return those values. So now I can no longer set the values from outside. It means I'm only going to be able to read from these static properties, which is a lot of times probably what you're going to do. So down here, if I take a look, I can create a few movie instances, let movie equals new movie, let movie 2 equal new movie, let movie 3 equals new movie, and then we should see that we can get back the counter and the init date because they're read-only. When we display these, sure enough, we get the movie counter is equal to 3, and there's our init date. You are allowed to have a static constructor in your classes. So a static constructor is called when the class definition is created. It's called before any other script runs on the page. It's only run one time, right? Not for each instance, but only that time that class definition is created. Now, it's interesting, you can have more than one static constructor. I'm not sure why you would need this, but it is possible. Now let's take a look at creating static constructors in JavaScript. In this HTML file, I've created my class movie. I have the 4 public properties. I have my constructor that increments the pound counter, so just like before. But now we have a static constructor here on lines 49 through 55. This static constructor is just static and then your block of code. When static has nothing after it, that is considered the constructor for the class. So in this one, I'm using now the static constructor to initialize the counter and the init date. Whereas before I was just initializing them up in the declaration, now I'm doing it in the static constructor. Either way is fine. It just depends on if there's maybe something else you want to do one time in this constructor. And that's it. So after that, everything else is pretty much the same. We can create a movie, we can look at the counter, we can look at the init date, and we can check that to make sure that after 2 seconds, it's still the same. So if we run this, we see the data, and then again, 2 seconds later, we see the same data because it's once for the class, not each instance. Also notice the first line in this window is in the static constructor. Do you see that? Then it says script is starting. So let's go back. I want to point this out again. Remember what I said, that when the class is created by loading the page, that's when the code in here runs. So there's that console.log in the static constructor. Then you see this is the first line within the script, right? So then we saw script is starting. Okay, that's why you saw this first, is because right when that page loads, before any other code runs in the script area, these static constructors are run. And let's take a look at static class methods in JavaScript. Same thing, we declare the static methods as public, and it's the same functionality as any of the other methods, it's just static, so it means you're going to access it through the class name. One of the most common things to do with this is create a clone method. Let's take a look at static class methods in JavaScript. In this HTML, I'm creating my class movie with the 4 public property definitions. I've created my constructor. I'm now gone back to just the regular movie counter and init date, public static properties. I have my static constructor that initializes the date. Then I have this static clone passing in a movie, and I'm going to let clone equal to a new movie, and then I will assign, by using the object.assign, I'll clone that data coming in by moving it from the movie into the new clone, and then I'll return that clone. So down here, if I let movie equal to new movie, and I pass in 1, Young Frankenstein, comedy, Gene Wilder, Marty Feldman, and I get the movie information, we will see that. Now what I'm going to do is I'm going to let clone equal to movie, uppercase M, dot clone, passing in that movie. Then I will change the name on the clone instance to changed movie name. And when we display that new movie data, you'll see that that data has been changed, at least the name property. And if we were then to display the original movie data again, we'll see that that hasn't changed. It is indeed a true clone of the movie object data. And then we'll display our movie counter. So we see the first instance of it. The second one is the clone, where I change the name property to be changed movie name. The last one here is the original one. You can see nothing changed there. And my movie counter, of course, is 2. Now I typically use static properties and methods for helper classes. This is where you might accept some data and return some data. Nothing needs to be held, right? No state needs to be managed. So if we're not holding on to any state, this is a really good example of where to use static. Examples are console.log. Log is a static method on the console object. Number.parseInt, number.parseFloat. You pass something in, you get something back. There's no reason to hold on to anything. The math object has math.min and math.max, for instance. JSON.parse, JSON.stringify, date.now, date.parse. These are all examples of built-in static methods in JavaScript. So let's take a look at creating a math helper class in JavaScript. Now, while this really isn't necessary, it's a very simple example just to get the point across that when you're creating these helper classes, they're typically going to be a class and you're going to have all static properties and methods in there. So this one, the math helper, has a static getPy, static add where you pass in two operands and it returns the result of adding those two together. Another static method is a multiply, again passing in two operands and returning the result of each of those multiplied by one another. So I would include the script here on this HTML page, and then I can call mathhelper.py and spit that out on the console window. I can on line 33 do a mathhelper.add, passing in 42 and 42, or mathhelper.multiply. So these are just very simple examples of what you might use these static methods for. And let's take a look at one more, and that would be an application settings class in JavaScript. This is also another helper class that you might create. So here in this application settings.js file, I have a class application settings. I've got a private static pound API URL and static pound port. And then I have two gets, right? So two getters to return that information. Then I've got a static method called load. And this is where you might go out and load these from a configuration file or something. In this simple example on the file system here, I'm just simply hard coding a couple of values. And this might be where you're making a web API call with the fetch API to go get something. You need the API URL and you need the port number. So again, in the application settings.html, I would load the script with that application settings class. I would call the application settings.load. It goes out, maybe grabs the information from a file, puts it into those properties that I can then display on the console window here using lines 29 and 30. If we run this just to show you what it looks like, you can see the two values here. So in this lesson, you acquired knowledge on utilizing the static keyword, you developed some static properties and methods, you implemented static constructors, you designed some really neat utility classes. In this module, we analyzed terms related to object-oriented programming, we developed classes that includes properties and methods, we implemented public properties utilizing getters and setters, we gained knowledge on establishing read-only and write-only properties, we established private fields within classes, we acquired skills to inherit from parent classes, and we implemented static properties and methods. So where do we go from here? Well, check out my From Zero to JavaScript Fetch API course that I have up there. Also coming soon are more From Zero to JavaScript modules, including templating, asynchronous programming, exception handling, array manipulation, set manipulation, data type methods, modules, DOM manipulation. So be sure to subscribe to my channel so you can keep up on all the latest modules I'm going to be releasing in this From Zero to JavaScript course.